Hello everyone, welcome back to Calculus 1, and we are still in section 3.3 about differentiation rules. And this time we'll talk about the last rule, really. The last rule in the section, quotient rule. And remember, in the previous part, we covered the product rule. I really want to have those two rules together. I want you to see those two rules together, okay? This is a product rule how I present. And also keep in mind this kind of long-fashioned formula, it is really the same as this short way of writing, okay? I use u and v. So derivative product, it is u prime v plus uv prime. And for the quotient rule, I'm going to use notation u and v again, not f and g anymore, okay? So specifically, I do have the following quotient rule. Derivative u over v is u prime v minus uv prime, right? U prime v minus uv prime over v squared. And as I'm saying, you really want to compare the product rule and the quotient rule. Okay. Certainly, these are different rules, but anyway, they do involve with the same terms, u prime v and uv prime. For the product, you take the sum of those two terms. For the quotient, you take the difference of those two terms. And also the other thing about the quotient is you needed to have denominator. So the denominator, it is the original denominator squared, v squared. Okay. How about let's take a quick look. If we are considering a function of e to the x over x squared, so clearly this is a quotient. I'm taking u as e to the x, v as x squared. So u prime, it is e to the x, v prime, it is 2x. And then using the quotient rule, okay, derivative of this quotient, and from this formula here, plugging everything for each notation, u prime v minus uv prime, x squared, that's x to the fourth. And actually, I say probably it should be better if I simplify it. I should have this simplified. Let me try to see if I can simplify this. So this really could be further simplified as Control C. Yeah, this should be simplified because clearly x is a common factor, so we can cancel one x greater than 2x. This x is canceled, and then denominator x to the 4, I believe x to the 4, it will be just x to the third power. Cancel one x here. This is derivative of e to the x over x squared. And then if we work with the derivative of x squared over e to the x, and you are going to take u and v differently. U is x squared, v is e to the x. So u prime, that's 2x, v prime, it is e to the x. And also this time, in speaking of simplification, I believe all the work I did, it should be all right. And to complete the simplification part, e to the x can be canceled. Cancel e to the x from the first term, and cancel e to the x from the second term, and cancel e to the x from denominator, e to the 2x, that's simply e to the x. Yeah, I think now for both, I've got the simplified answer. Simplify the answer here. Quotient rule. How about let's take a quick look about the examples on the textbook. So first one, it is example 3.25. It is from the textbook directly, derivative of k of x. I'm taking u as 5x squared, v as 4x plus 3. And certainly, I suppose we do know up and u prime, the v prime, very well. And then use the quotient rule. I copy and paste the quotient rule right here. Okay. And then plug in each expression for the corresponding notation. And then actually I did a little simplification here. So this is 40x squared and then minus 20x squared. So it turned out to be 20x squared. 10x times 3, that's 30x. So I believe this should be the simplified answer. Okay. If you see something different, just let me know. And one more example from the textbook, it is checkpoint 3.17. Find the derivative of h. So u is the numerator, v is the denominator. Then we got a u prime and a v prime. And again, using the same quotient rule. I did repeat the formula, and I hope you got some idea how the formula works. Okay, how the formula works. And so plug in each expression for the corresponding notation, and also there's a little simplification from the numerator part. Usually for the denominator, I would say for this type of problem, you want to keep the denominator as it is, unless there are common factors for the numerator and denominator, then you simplify. Otherwise, I would say especially you want to keep the denominator as something squared as it is. Okay. So in the end, for this particular one, 3.17, I'm having the answer like such. Quotient rule, quotient rule. So basically, this concludes the discussion of section 3.3, differentiation rules. We got a few rules, okay? And remember the power rule, the power rule. This is the power rule I'm talking about. Well, the power rule is here. Power rule. And then we have the exponential rule, which tends to be derivative of itself. And also we have the sum and the difference rule. Then we have the constant multiple rule. And we also have two little more complicated rules. The product rule and quotient rule. Let me know if you have any questions. Thank you for watching.